Hello, everyone. Welcome to this episode of the Intelligence Spotlight series. And this episode, I'm thrilled to welcome Faissal Sharif to the Intelligence Spotlight series. He is a neuroscientist at the University of Oxford, where he explores neurotechnology's role in mental health treatment. As a co-founder of Memnoon, he's building a mental health platform tailored to BIPOC communities. Faisal also leads the neuroethics division at the Institute for Internet and the Just Society, focusing on the intersection of neuroscience, technology, and ethics. A passionate advocate for innovative mental health solutions, he is bridging science, society, and digital health. And now let's dive into his fascinating insights. Faisal, first question. You've been traveling a lot, and why do you travel a lot?
First of all, guys, thank you so much for having me. And thank you for the nice intro. I do like traveling actually. So for professional and personal reasons, I was able to live in 6 different countries. So Philippines, Netherlands, Hong Kong, US, and now currently based in the UK. So that allowed me to experience a bunch of different cultures, talk to a bunch of different people, improve my neuroplasticity to kind of stay in neuroscience terms and to make sure I'm as open-minded as I can be.
That's interesting to witness. I think you traveled to 75 countries, if I'm right.
Yeah, that's correct.
Yeah, that's an achievement. Actually, you already broke the goal I had, and my goal was to do 100 countries within 10 years. And that was in 2015, actually. So I'm way back in that regard, maybe like 20 countries maximum. But
Wait, and you had the pandemic as well, making it a bit more difficult to travel.
all right. Thank you so much for joining this episode of the Intelligence Spotlight series. I want to know really, really interested to know your story and how you decided and landed in the realm of neuroscience. What were your inspirations and motivations, especially for a person coming with a migrant background? I think your parents actually moved to Germany. So far that I know, it's really inspiring to have a person working in this field. So tell me about it. Let's get into your story. And for our listeners, I'm sure they're excited too.
I grew up in quite adverse circumstances where there wasn't a lot of kind of inspiration around me, I have to say. But I was quite lucky. I had a great biology teacher that really encouraged me to go deeper into biology. So I was very interested in sort of how genes work, how cancer works. And for me, it was always sort of like the essence of nature and the essence of human health that sort of in its purest form doesn't see any kind of political issues or like differences between humans. It's sort of like a cause that for me felt very universal and something that's not quite not as constructed. So for me, working on kind of the field of healthcare was always something that I felt quite connected with. So then I decided to study biomedical sciences in the Netherlands at Maastricht, where we basically covered the entire human body, the entire human physiology, right? So every organ system. And one of the organ systems that really fascinated me was the nervous system. So we learned about aspects of mental disorders. We learned about degenerative disorders, such as, for example, Alzheimer's disease. And found it very interesting to know and understand what arguably is the most complex structure in the universe. I mean, the human brain has about 90 billion neurons, all of which also have trillions of connections to one another.
Wow.
So synapses. And there's more neurons in the brain than there are stars in the Milky Way, right? So studying this for me meant I was able to unlock parts of human nature, human consciousness, human experience as a whole, every kind of phenomenon that we experience, every bias we experience, every memory we have somewhat encoded in the brain. So I kind of went ahead and with the encouragement of mentors that I had along the way, for which I'm very, very grateful for, I was able to get some scholarships. I did some research in the States in California where I worked on like early detection of Alzheimer's disease, which is a huge problem
Mm.
nowadays as the kind of life expectancy increases, and we have more and more diagnoses of Alzheimer's disease. And then I was kind of like locked into kind of neuroscience, moved to London to study the brain at Imperial, did a master's there where I focused my research a bit more into the sort of like mental health space. I was working for the Center for Psychedelic Research under Robin Card-Harris, David Nutt, David Arizzo, which at that time was really a new and kind of re-emerging field, right? Like psychedelic science, trying to understand how psychedelics can unlock questions about consciousness, questions about mental health um, that we have because of sort of like the kind of regulations that slowly were softened and made it possible to study psychedelics among other scheduled drugs. So in this research, I really looked into, okay, what is the effect of that substance on kind of personality, on mental well-being? Could it be used for depression? And also sort of, what does it tell us about consciousness, right? And it's exactly this sort of like interplay between biology, society, philosophy, sociology, and so on that really fascinates me and that kind of allows me to connect neuroscience with other fields as I'm doing the work in, for example, neuroethics.
Mhm.
Um, then after kind of some stints in kind of neurotechnology and like e-health, where I was working for a startup where we looked into kind of utilizing wearables for mental well-being and kind of using that as a prescription digital drug.
Mhm.
I moved into consulting and then ended up full-time as a researcher at the University of Oxford, where I'm now looking into how can we, first of all, understand mental disorders better, right? Understand whether the current system of diagnostics, which is a Western centric system, and it's a very old system, still makes
Mhm.
sense, right? So the way we diagnose disorders, does that make sense? And also at the same time, can we use and leverage neuroscience to help uh, understand the kind of progression of, let's say, depression and anxiety over time, and use neurotechnology to alleviate symptoms as well.
Mhm. And I'm sure it doesn't come easy. You've had a lot of your hard moments as well as a neuroscientist, having experienced anxiety and stress and exploring all of these subjects too.
Of
Uh,
course, right? Yeah, yeah.
yeah, yeah. It's always fascinating to know that. So a lot of times we do have people trying to understand how their mind works and how generally when they're trying to make a decision, what actually affects their decision making sometimes if they're in different sort of situations. So for you, what is actually is the cognitive bias and how do these biases, such as confirmation bias, affect the decision making process? And whether a neuroscience specifically say anything about it and about our brain?
So you're asking a bunch of very big and complicated questions. So bear in mind if I kind of start off by giving a quick crash course in cognitive neuroscience, because I
Let's
think
go for it.
we need to kind of establish some of the kind of fundamental principles of that we
Mhm,
know how the brain works in order to go into these biases, because they're very, very closely connected, and
mhm,
you'll see why. First of all, our brain is not what many people believe. It's not just integrating things that happen around us. Our eyes are not just a camera. Our ears are not just a microphone. It's not like the environment is happening to us and then we make sense of it. That's not how the brain works. And this is what kind of cognitive neuroscience has been telling us for the past decades, is that instead of the environment influencing um, our decision making, we already have models of the environment stored in our brain that we then try to compare with um, stimulus and kind of cues that happen around us. And I'll go a bit deeper into this. So what I mean with this is hierarchical predictive processing. We call it kind of top-down processing. You essentially have all of these different inputs, right? You see something in your environment. Let's say you you're in a bustling city, and you go into a train station. Let's say in London, there's a bunch of people, And you have all of these sort of like sensory cues, right? You have kind of noise coming in, you have visual stimulus, you see hundreds, if not thousands of people at the same time. You see storefronts and signs, a lot of visual information. And our brain would be extremely inefficient if it even tried and attempted to process all of that information at the same time. So what needs to happen? We need to kind of build a filter and narrow down what is relevant and what is not so relevant, right? And this filter is exactly where kind of this hierarchical predictive processing comes into play, right? We have the sensory cues, the sensory information coming from kind of lower areas, literally lower areas of the brain, and being mediated, or you could say filtered or suppressed by kind of higher order areas of the brain. And these filters basically say, look, all of these people don't pay attention to them. What you're interested in is like find kind of your, let's say, your platform. So you
Mhm.
know what a platform is. You know roughly how like the toll gates work. You know roughly where to navigate, and you know that everything else is irrelevant. So basically, because you've seen hundreds of train stations before, and maybe in that particular train station you've been before as well, so you have memory informing um, that perception. It's way easier for you to navigate, and you can literally go straight to the platform and find your way. And this is sort of like the way our brain represses and makes sense of the world. And essentially, what is happening is our brain is predicting what it's about to see, right? When I'm in a train station, I can already predict what I'm probably going to see based on hundreds instances of that experience. When I see an apple and I'm about to bite into it, I can predict and know already how it's going to taste like based on thousands of instances of me biting into an apple. So we always already have a model, right? And
Mm.
that's an important word. We have the model for what's going to happen around us. So we know that the brain encodes the world in models, and these models are essentially summaries of summaries of summaries of summaries of summaries, right? We try to put all of these hundreds and thousands of instances of experience that we have together into something that makes sense. Similar to, for example, um, ChatGPT, right?
Mhm. Mhm.
So when I give a, let's say, a New York Times article, I copy the article, paste it into ChatGPT, and I say, summarize this article in 5 sentences. If I give this prompt to 5 different LLMs, to 5 different versions of ChatGPT, I will get 5 different summaries,
Right.
right? Because the different models, the different algorithms pay attention to different things because
Mhm.
their model is different. Their model of like what is important, what is the gist of it may be different. So you can have one article and have hundreds, if not thousands of different interpretations of what is the most important feature. And the same way, that AI is different, that algorithm is different for everyone using it. Our models are different between humans, right? So my model for how I kind of have a social interaction may be different to your model of having a social interaction. My model of like the way I listen to music may be different to your model um, of listening to music, right? And what can happen is similar to, again, I'm sticking to kind of AI and machine learning terms here. Um, Perhaps you heard of like underfitting and overfitting. So essentially building a model that is too specific, right? So I go into a train station and I
Mhm.
go in and say, well, this doesn't look the train station like a train station in Berlin. Therefore, my system, my model doesn't apply, right? That's overfitting, where
Mhm.
basically I'm focusing on irrelevant details. No, it's still the same category. It is still a train station.
Right.
And then there's underfitting, which is basically I look too much into the big picture. I don't have a lot of information, but I already applied my model. And underfitting is, and perhaps now it gets a bit more relevant for the whole idea of cognitive bias,
Mhm.
that is
Mhm.
jumping to a conclusion, right?
Right.
So I'm jumping to a conclusion because my model is not matured, or I don't want my model to mature. And my model doesn't mature because it's efficient. It works, right? If I already have the summary and like I can navigate the world, why should I update it? Our brain, just as every other thing in nature, is a physical object. It follows
Mhm.
the orders of physics. And in the way physics work, right, we always look for the path of least resistance. And these
Mhm.
models, if we translate them into actual kind of neurobiology and like things that we can measure, these are kind of pathways in the brain that are kind of connecting strong and stronger over time. Perhaps we heard of this term called neuroplasticity, right?
Right.
And these pathways become kind of from like paths turn into kind of motorways, into huge multi-lane highways. And there's sort of like a whole Autobahn situation happening in my brain, cars going back and forth, back and forth. And why should I take a different route if the most efficient way for my brain to compute information is taking the Autobahn? So our brain, when we have cognitive bias, when we jump into conclusion,
Mhm.
when we buy into fake news, is doing what is most efficient for its state at that moment.
Right. So you
Because
don't want to
because
take the right. You don't want to figure out where the way is. You just go what you see, basically.
and you're not even aware of it, right? So
Yeah.
these are like automatic thoughts. And this is interestingly, because I'm doing research with mental disorders, that's exactly the same thing that happens in depression, right? So in depression, you have this thing called NAT, negative automatic thought, which is basically just an autobahn that was built the wrong way and you're ruminating over like a negative core belief, right?
Mhm.
So, oh, like people don't like me, or there's no point in me going outside, and all of these sort of like negative self talk. If you
Mhm.
do it over and over and over again, and there's no reason for you to challenge it, it becomes the most effective way to go about your life.
Right.
And we can measure these pathways, right? We can look into, like, if you want like to hear the technical terms, we can look into kind of the default mode network. We can look into the salience network, and we can visualize these things using, let's say, fMRI scanner that looks into
Mhm.
kind of how the kind of functional anatomy of the brain looks like. Um, but we don't even need to do that in the question of cognitive biases because we already know, okay, we have these kind of this system of models, and we have news, and we have
Mhm.
fake news that don't exist in isolation.
Mhm.
So I, and I'm not an expert, you're the expert here about fake news, but fake news don't have come out of nowhere. They usually feed into a narrative that already exists,
Right.
right? So if I, for some reason, am subscribed to that narrative, that new piece of information, this fake news, if it feeds into my narrative, it is again the path of least resistance, right? Why should I update my beliefs or update my priors in that sense to accommodate this? If the brain always wants to reduce prediction error, right? Always wants to make sure that the model is correct. If I
Right.
have a piece of information that is challenging my model, what is activated in the brain are areas that are quite similar to the areas that are activated when we actually have a physical
Mhm.
threat, right? So
Yes.
sometimes you have like this kind of physical anxiety, and maybe you have it when you argue with someone where you like it is just a conversation, or it's perhaps just a debate, but there's like almost this defensiveness coming in because you see nervous systems trying to regulate each other, trying to find an equilibrium, even though you are in completely different spectrums of ways of thinking. And even though you all have each have your individual matured pathways already pre-built.
I'm always fascinated because misinformation online directly impacts how people actually perceive them. Because, in one hand, if something happens, there is this emotional element to it that touches. And I think what happens in that situation is that, at least from what I understand, is that the brain automatically puts certain curtains, which are created by emotions, and stopping people from critically thinking, trying to navigate within their brains to question things. And I think this takes us to the next question of how does the brain process the information, after all, in different situations when it's under stress, trauma, anxiety, or special, or during a societal crisis, like something, let's say, as an example of suddenly a country's government is changing or there is an economic crisis, and how susceptible the human brain becomes to misinformation in this regard.
Yeah, I mean, you touched upon a brilliant point with the kind of the curtain.
Yeah.
So, like, talk to any salesperson, talk to any marketing person. They will tell you that we don't make rational decisions, we make emotional decisions, right?
Hmm.
So we're much more susceptible to our emotions defining our actions rather than what we kind of believe is rational. Even though in the brain, what are emotions and what is sort of cognition, it pretty much overlaps, right? So
Right.
what is feeling versus what is cognition? Well, it all happens in the brain anyway, right? So a lot of neuroscientists would tell you, okay, it's a bit of a hard distinction to make between the two. Um,
Mhm.
but there is again sort of on top of what we just talked about with models, the benefits of kind of the social proof, right? There's sort of like the social psychology aspect of, let's say, I follow a certain conspiracy theory, right? And I have people around me that validate that conspiracy theory. And similar with racism, similar with um, kind of misconceptions about certain things, or even kind of, and in terms of a country switching radically in terms of government, right? Political alignment,
Mhm.
right? So oftentimes like parties, you reinforce each other in your beliefs, and you kind of subscribe to a kind of thought collective where you're you're trained to not really tackle the opposing view, but rather to kind of like go and work around it. This typical way of like cognitive dissonance and cognitive bias, where you try to not update your model, even though
Yeah.
perhaps objectively you're wrong. In terms of stress and anxiety, it has some implications on how flexible we are in terms of processing information.
Mhm.
So it has sort of, it's like a two, I would say it's like a two-edged sword. So on the one hand, if I am in an acute threat or anxiety state, right? So anxiety being there's a threat that is not very proximate, whereas with fear, the threat is right there, right? And then the
Mhm.
next step would be perhaps shock or panic. Um, with that sort of form of kind of anxiety building up, obviously your sympathetic nervous system, your fight or flight reaction would start kicking in. Your pupils will dilate. You have higher levels of cortisol. You essentially have more energy that you can utilize more quickly. And what that
Mhm.
does to you, it sort of is this instant caffeine shock where you can process a lot of information very quickly, but it comes at the cost of cognitive flexibility,
Mm.
of the ability to kind of shift and sway in certain areas and kind of be you're less flexible with your thinking, and you're less flexible with like your uh prior thinking and prior beliefs, and perhaps adjusting your beliefs. Data has been showing with like the increased stress of conflicts around the world and the pandemic and the reactions and so the aftermath of that, what we see. I mean, there's the Reuters Institute findings where they talk about news avoidance going up, like something like 69-70% of people occasionally avoiding news whatsoever, right? It's not about
Yeah.
fake news or like misconceptions. It's just about kind of completely closing that curtain that you mentioned
Right.
to any new piece of information, because they associate the new piece of information again to this sort of um, negative emotion of things that happen around them, but they see it affecting them emotionally a lot
Mhm.
more. So there's definitely a link between kind of stress, anxiety, and the way we approach news and approach information.
Mhm. And you were talking about validation also as a reward mechanism for the brain that actually, when you have a certain belief into a theory or information, of course, if others are saying the same thing, kind of validates your own understanding of it too, right? So, on the validation itself, how addictive it is if we consider it in all the different aspects of information that we consume, and also the way we present ourselves in the, let's say, in the digital world, particularly, how addictive it is, and whether there are ways for people to reduce that validation and open up to other ways of maybe that reward mechanism,
Mhm.
you would think?
I think there's a system side to your question and then kind of like an individual action side to the question. So on a system side, in terms of like seeking validation and not really being confronted even with information that is opposing your views, I think obviously a lot of it has to do with the kind of the emergence of echo chambers and algorithms and us kind of feeding into what we perhaps already know, right? And you see this not only with news, you see this with activism, you see this with in all kinds of different digital spaces where it seems we really create more and more divisions.
Mhm.
And there's some very, very interesting data on that, on, for example, how your Twitter algorithm can predict your voting behavior and all of these kinds of things. So obviously we live in a system that kind of, because it's an attention economy and the the big platforms make money based on how much time you spend on the platforms. There's
Right.
an incentive towards getting people hooked, right? There's an
Mhm.
incentive towards um, BuzzFeed type media, which is listicles, ultra short form content, and all of these things where there's no time to
Right.
talk about nuance and balanced point of view. It's literally just 240 characters or like 20 seconds, a TikTok or reel. Even the founder, the CEO of Instagram talks about how for creators, it's so important to get people hooked in the first couple of seconds. If everyone is incentivized to build that hook, maybe that hook itself is not that informative, not that nuanced, not that
Mhm.
real. And maybe some people make more use of that compared to other people. And we see how it plays out with kind of governments interfering with paid content on social media and all of these things. So that's like really kind of the system question where I kind of want to take away a little bit of the responsibility from the individual because I think we are all part of a greater system. And if it's, um, it is a collective aspiration. I hope so that we kind of lift those constraints of the system and allow individuals to kind of breathe a bit more freely and be able to kind of consume media that is um, a bit more balanced. On the other side, when it comes to the individual basis, literally asking yourself this question, right? Like I'm asking you right now, when was the last time you drastically changed your opinion based on a piece of information that you read?
Mhm. And I think that comes also from a belief of a belief system that, okay, I have to be a person open to other opinions. This is a belief system that you actually believe in and that you think it's a way for your progress. But there are also ways that, especially when it comes to religious beliefs, that people, once they have a belief, they're saying, I will never listen to another person's belief telling me how to, believe in that regard. And then there's you have blocked the way. That's what I think, at least. And I don't know whether that's the case or it just also because there are people who are open to different ideas and they may question it, first resist it, and then think about it, reflect on it, and then they open up about it and try to research and know more about it. Because this was the same thing for me in the field of open source intelligence. First, when I confronted it, I wasn't sure that I would do it. And then it made me curious. And then I looked at it, researched it, and then I got into it. So, but I never thought I would do this. But the thing was that once you have that open mindset, I guess it gives you a lot of opportunities. And that mindset in itself is a belief, I guess. And that sort of, what do you think about that?
It's so you sound like what you described. You sound like a very open person, and
Mm-hmm.
openness is a personality trait. It's
Mm-hmm.
part of the kind of big five personality traits that we study in psychology. And you can kind of score low on openness. I mean, in terms of kind of the normal distribution within a population, or you can score above average in
Mm-hmm.
openness. And openness predicts a bunch of things, right? And openness predicts voting behavior. Openness predicts divorce rate. Openness predicts things like whether a person traveling a lot or not. So I
Mm-hmm.
think openness to new information, to experiences, to new beliefs, um, it's a personality trait that can change over time, right? Our brain
Right.
is neuroplastic and we can become more and more open-minded. And I'm sure we all have people in our environment that we see kind of becoming more open-minded or perhaps more narrow-minded over time. So you can shift um, basically over time.
Mhm.
But one powerful thing to do, um, and it's not only relevant for fake news and sort of like media, it's something that's very powerful in general, is this idea of cognitive reappraisal. You
Mhm.
kind of, you have a thought, you have a belief, or interpret a situation. And after it happens, you look back on that situation. So either you write it down, right? And you journal about it, or you talk to someone about it, or maybe you do therapy and you have a counselor and you have a
Right.
conversation about it. And then you reframe it. You distance yourself, your individual person, your ego from that thought and look into, okay, was I emotionally loaded when I said this or thought this or when I interpreted this? If I just look at it as a statement, like would I subscribe to it again? And
Mhm.
oftentimes we are made to be quite emotional and we're made to be kind of very um, maybe cognitively inflexible by the way news and media is presented to us, right? It's literally people fighting on TV, right? Arguing on TV. And sort of we kind of try to kind of go this way, the other way. Or maybe kind of take a break and say, okay, I need some time to reflect on this. And you can reframe your thoughts by saying, well, um, instead of saying, for example, this is outrageous, I completely disagree with this, you
Mhm.
can reframe this into, I experienced this as something outrageous. I
Mhm.
experienced this as something that's out of my comfort zone.
Right.
And with this sort of like distancing yourself like from yourself with that thought, you're usually able to grasp a much more nuanced um, way of coming to a conclusion. And it's in this nuanced way, and it's exactly what you're describing, right? Like now you go into the nitty gritty and you fact check and you do all of these background checks. Perhaps not everyone can do this. Maybe not everyone will go this far. Um, and also in terms of kind of delayed gratification, right?
Right.
And see kind of really seeing the reward of the fruits that come from like actually doing like a lot of research. Maybe not everyone will have this experience, but one thing you can do is at least slow down in your
Right.
thinking. And it's like, I don't shy away to tell someone, I don't have enough information about this to to form an
Mhm.
opinion. I think the age of internet perhaps exacerbated this idea of, I need to have an opinion about everything,
Right.
right? Good, bad, right? It's usually black and white, but sometimes you just don't know.
Yeah.
And because you don't have enough information,
Mhm.
the amount of misinformation that was around regarding COVID drove me nuts, right? Where people talked about how acidity in blood can causes cancer and how sugar is involved in everything. And it was just a huge amount of misinformation. And I'm like, that's one of those moments where I'm like, you don't need to have an opinion about everything. If you don't know, if
Right.
you have no expertise,
Yeah.
let it be.
Yeah. And I guess that also brings us to another part about how to build resilience, right? We live in a time in our lives, and maybe in many generations, we are the very unique generation that have access to a lot of information, and we consume information, a lot of information in a very short amount of time. Let's say if something happened in the 60s or in the 50s, people wouldn't know right away, and even one news would travel, and they at least the fastest was 24 hours later after it was printed on the newspapers. But the more we progressed, faster information is spreading, the faster we consume, the faster we create. And the more crises we have in the world, the more information are there. And it's hard to distinguish what's real, what's not. And that's why a lot of people fall into the trap of misinformation that are being spread, which is sometimes is unintentional, but it's not verified yet. So, how to build that resilience in our brains and train our brains to better defend ourselves against misinformation? Or what suggestions you have in that regard?
Yeah. Great question. So So one of the points would be what I just mentioned, right? Which kind of feeds this idea of like cognitive behavioral therapy, where we
Mhm.
distance ourselves from the thoughts and try to reappraise them, reevaluate them, write about them, kind of look into them in a different way, in a different modality. But there's also actually ways in we can improve our cognitive flexibility, right?
Mhm.
So how does cognitive flexibility look like in the brain? Well, it's basically a chemical. It's called BDNF, right? Which is brain
Right.
derived neurotrophic factor. And BDNF can be increased by
Mhm.
lifestyle interventions, right? So
Right.
if I do regular physical exercise, especially high intensity exercise, I am more likely to have high levels of BDNF, which by the way is lowered in a lot of mental disorders, including depression, right? So there's a correlation there as well. Um, if I have quality sleep, right? If I, for example, during, especially right now, right? It's like shorter days, winter time, um, having kind of some sort of light therapy, vitamin D interventions that help with kind of keeping our melatonin levels and our serotonin levels regulated. That helps as well with neuroplasticity. And of course, mindfulness, breathing, meditation, all of these things have been known to get you into a state of higher neuroplasticity. And I mean, if you think about it, all of these things relate to a slower lifestyle.
Right.
And if your lifestyle is a bit slower, if you have like this kind of digital detox or dopamine detox, you are perhaps less prone to feed into this sort of very quick way of thinking.
Mhm.
And sometimes quick thinking is not the best way of thinking, especially when it comes to building resilience and kind of tackling information. So I think taking a bit more time, slowing down is a great way to achieve resilience towards what you've mentioned, right? Different pieces of media, different pieces of information.
Right, right. Yeah, that's very much crucial. And I think you repetitively said that to take a step back and try
Mhm.
to, even it's fine to sometimes cut off the news if you can't handle processing them. So it's better to not be aware of it for a time until you know you can process. You've been also doing a lot of research into neurotechnologies as well. So what are the potentials of it, and whether these digital tools could be used for improving cognitive functions and especially in reducing biases, or how do you see that in the long term?
Sure, great. So with neurotechnologies, maybe we perhaps start by defining what is neurotechnology. So it's essentially any way you interface digitally with the nervous system.
Right.
And the nervous system, meaning the central nervous system, so your physical brain, your spinal cord, but also the peripheral nervous system. So any nerves in like your limbs, for example, your arms, your fingers, would also be part of neurotechnology if you were to interface with them. There's right now the main focus of neurotechnologies are for health reasons
Right.
and to restore normal function, right? And you can see this very pertinently with Neuralink, where
I
like
see.
Elon Musk was like, oh yeah, we will have human interfaces and we can read each other's minds. But what they're actually doing in reality is they're giving quadriplegic patients a way to control the mouse, right? So
Mhm.
at the very basic level, it is to restore normal function, let's say motor function, right? Or like if you don't want to control a mouse, you move like a bionic arm because the signals emerging from your brain are picked up by an interface and interpreted. Okay, is this brain signal meaning up or hand down or like lift
Mhm.
arm, move arm left and right, right? So you need to calibrate it over many, many hours. And once it's calibrated, it basically knows what to do. And then you have like kind of this kind of bionic cyber-esque extension of the human, right? So
Mhm.
that's currently and realistically what is the focus of neurotechnology. Another way would be deep brain stimulation. People with, for example, Parkinson's disease, they would have trouble moving because of irregularities with their dopamine production. So they would get like an electrode deep inside their brain that would stimulate a particular brain area, and that would
Mhm.
allow them to have less shaking, less tremors. So again, restoring normal function.
Right.
However, we are, as we're emerging and as we're kind of like pushing new frontiers with these technologies, we have more and more questions about, okay, what about other not health related uses of this technology? Or what if, for example, Neuralink, what if we established it was completely safe to be implanted?
Mhm.
And what if we thought about implanting it in healthy participants or like in healthy individuals? So that allows us to think about this whole new field of what we call cognitive enhancement,
Right.
right? And this is something, I mean, sci-fi, and if you have watched movies like Gattaca, for example, or even Black Mirror, there's many references of kind of what happens if we let technology extend human
Mhm.
cognition? What happens if we let technology create a new way of like what consciousness could mean? And a lot of it is more theoretical. However, some things are actually quite close to being reality. And this is also one thing that I'm working closely with and writing about with my neuroethics work is ways in which these brain computer interfaces allow agents, allow individuals using the technology to read
Mhm.
data information in the brain and also to manipulate data in the brain. Right. So one thing is stimulating,
Yeah.
which is, for example, with the deep brain stimulation. Another thing is actually receiving information, and both of which have potential applications. So, for example, if we look into Jack Gallen's lab at UC Berkeley, he is working on something called visual reconstruction. What does that mean? He is essentially building algorithms that can detect or predict what you are seeing only based on information from the visual cortex. So he puts people in a scanner and they watch like a series of videos or like images,
Mhm.
and then he takes away the video and is having the kind of algorithm be trained, and then uses that algorithm to predict what is a person seeing.
Mhm.
And if you look that up on YouTube, visual reconstruction, it is actually quite interesting how far we've come. And I think with the kind of advent of machine learning, it could become even better. So we can already tell based on brain sequence alone whether I'm seeing a shape or perhaps letters or if I'm seeing a face.
Mhm.
And nowadays, just I think 1 or 2 years ago, we have uh, labs working into reconstructing audio. So without knowing what a person is actually hearing, just based on brain signals alone, reconstructing audio. And these things are interesting, but also scary. Why? Because they raise questions on mental privacy or neural
Right.
privacy. And so who owns my brain data, right? So perhaps you've read 1984, George Orwell saying the only space that really belonged to us were like the few cubic inches inside our skulls.
Mhm.
But now even that ownership of the brain may be um, in danger because of kind of the advent of these technologies. And of course, there's always like with good implications of these kind of advances in neurotechnology, there comes some ethical questions as well, which is why, for example, Chile, the government of Chile was the first country in the world to put mental privacy as a right into their constitution. So your
Wow.
mental privacy is protected in Chile. Now, last year, the OECD published guidelines for ethical use of neurotechnologies. UNESCO is also supporting this. So it is becoming a bigger and bigger topic. And it relates not only to kind of the big sort of tech giants, but it also relates to the, the court system, right? So are we using these algorithms to detect crime, right?
Right.
So there's Ken Keel, for example, in the US who's built an algorithm that can predict with over 90% accuracy whether someone has a psychopathic brain. And psychopaths, if you think about it on an ethical level, psychopaths have no societal benefit. There's
Mhm.
society does not benefit from the existence of psychopaths. Like it's a
Wow.
very strong statement, but it's not like maybe other disorders or like meant like where we can say it is part of the experience, but in most cases, psychopaths lead to some kind of negative outcome for society, right? So when we think about kind of mass murderers, rapists, and these kinds of things, psychopathic scores are quite high. So
Mm.
what if, hypothetically speaking, we screen everyone for psychopathy and we screen teenage boys for psychopathy, which, like, by the way, account for 99% of all psychopaths. Like, they're all male. So we screen them and we basically know, okay, you have a psychopathic brain. Now you need to do some kind of training to some kind of facility, or like we exclude you from society, right?
Right.
So these are questions, sounds crazy, but you would be surprised of how much neuroscientific evidence of like actual brain imaging data is used in the courtroom, in courts in the UK, in courts in the US every week. So like kind of neuro law is its own field already.
Hmm.
And with the advent of all of these technologies, we of course need to ask ourselves, okay, mental privacy, ownership of my data, is this something that like governments perhaps could, or like organizations, or like what kind of intentions would people have? Think about marketing could be exploited.
That's made me think of a very dystopian question. And I think that will be the last part of our talk. And it was a lot of information to digest, and for me as well. So, this question derives from the talk about whether we own our brains or not at the end of the day. So, do you think there will be a time that we actually don't need our bodies anymore and our brains will suffice the physical existence of brains only?
And no, that's an interesting question. And people have thought about this actually, right? It's called the brain in a vat thought experiment. So
Mm.
think about Matrix, the Matrix, for example, like you just have a bunch of brains and then they're connected to bodies. And I mean, that's what a lot of neuroscience is saying, right? I mean, we are essentially brains connected to our bodies, right?
Mm.
So that's why whether we have input from like our sensory organs or from other organs, artificial eyes, artificial cochlear implants, right, doesn't make a big difference because the brain is able to make sense of it. The, of course, I would like to think no, right? But if you think of it from like a clearly like very very simplistic neuroscientific point of view, the brain is connected to a body that is kind of deliberate with nutrients, with blood,
Mhm.
oxygen, of course. Our entire existence is stored in the brain. I'm not a dualist. I don't kind of
Mhm.
subscribe to the idea that sort of the mind, the body are separate. I'm very much a physicalist. So we
Mhm.
need and coexist with the matter that makes us a human, which is our brain.
Faisal, thank you so much for your time. It was a very informative session.
Thank you.